Questions 4, 5, and 6 on this worksheet. So now we're talking about a wheelbarrow, and it's lifting a 200-pound load, and we have the length from the axle to the center of the load, okay, and then the length to the handlebars basically from the wheel. So let me see if I can draw a good wheelbarrow. I'm not the best at it, but let's see how we. Oh, there we go. Look. Well, so embarrassing. Hopefully that's a good enough drawing for you. All right, so what are we going to do? We have to show the load. So the idea will be that I have a load right here, okay? And then we have the handlebars over here. So we have our effort force is going to be over there. I'm going to move this over a little bit. All right, so I have my effort force right here. I have my resistance force is going to be pulling down right there, okay? I have my distance from the center of the axle to the load is this distance right there. That's going to be our resistance distance, dr. Okay, and then we have our resistance or the effort distance, which is going to be from here all the way to there. So dE is going to be that. Okay, so I mean, don't embarrass if you can draw as good of a wheelbarrow as me. I'm just really good at art. All right, so here we go. First thing we need to do after we draw the picture, I mean, as good as mine, is we have to get the ideal mechanical advantage. The equation for ideal mechanical advantage is going to be I'm a deer again. So IMA is equal to DE over DR. Okay, so we're going to substitute it in. So our effort distance is the long distance of 5 feet. My resistance distance is really fun to say. That's going to be 2 feet. Okay, so we're just going to have 5 divided by 2, and our IMA is equal to 2.5. There you go. Now we're going to go static equilibrium equations. And again, we're assuming that there's no loss of friction because it says it earlier in the worksheet. So if you have no loss to friction, the idea is that your IMA is equal to your AMA. Okay, or more specifically, your effort distance is going to be equal to, and I'm going to zoom in a little bit, give me some more space. So my if my IMA is equal to AMA, that means my IMA, which was DE over DR, is equal to my AMA, which is, am I free, FR over FE. Okay, so now we can substitute it in. Our effort distance, we already have this part, and yeah, you could replace this whole thing with 2.5. I like to do the extra step, but you could just use your 2.5 and replace the IMA here. But I'm going to put my DE 5 feet over my DR, which was 2 feet, and that's equal to my AMA, which is going to be my resistance force, and that is what's actually going to get lifted, which was our 200 pounds. That's right there. So we have 200 pounds, and underneath is what we're looking for, which is our effort force. So that goes there. Okay, so now we got to do our cross multiplication. All right, so our cross multiplication, we're going to do 2 times 200 and 5 times the effort force. So we have 5 times the effort force is equal to 2 times 200, which we know is 400. So we have 400 is equal to 5 times FE. That's E. All right. Divide both sides by 5. Yoink, yoink. Okay. And we will get our answer, which is going to be 80. So there we go, 80. Whoops, I need to fix that. My units, and again, my units, we're talking about force, effort force. So that's going to be at 80 pounds of force. All righty, thanks for watching.